Hello everyone and welcome to MakeLearn 360. So in this video I will solve a question or some couple of questions with you to illustrate the concept of the axial loading and deformations. All right, so let's start with the first problem. So the length is giving us 18 meter or 18 meters long steel wire with a diameter of what, 5 millimeters. So diameter is 5 millimeters, is to be used in the manufacture of a press stressed concrete beam. Sorry, it is observed that the wire stretches. So when you hear stretches, then it means he's talking about the elongation, which is 45 millimeters. Okay, now when a tensile force P is applied, okay, so knowing that the E is 200 gigapascal, we should find the magnitude of P and the corresponding normal stress in the wire. So think about a wire like this, which where we have applied a tensile force. Okay, so once we have applied a tensile force, then it is going to extend, and that is what we are calling the delta. And then this is the actual length. Okay, so this is the actual length. Okay, and then the diameter, which has been given as well. So to find the magnitude of the force is sort of straightforward. We know that delta is PL over AE, right? And delta has been given. L, we know. In fact, the diameter will help us to get the area, and we know E. So we can first of all find the area, which is pi d squared, which is 5 squared over 4. So getting this area as this, then we can say that pi, so our area is going to be pi multiplied by 5 squared divided by 4. And what is that? 19.63. So the area is 19.63 millimeters squared. Once we know the area, we can go ahead and then solve for P. So P, making change of subject, P will be delta multiplied by AE divided by L. But we know, so P is what? Delta, which is 45, and then A, which is 19.63. So I'm dealing with millimeters, so I will have to convert everything to Newton and then millimeters. So E becomes 200 multiplied by 10 to the power 3, so that I can convert this to megapascal. Okay, then I will divide this by the length. And what is the length? 18 meters, which is the same as 18,000 millimeters. So therefore our load, so let's pick our calculators. Our load will be 45 multiplied by 19.63 multiplied by 200 times 10 to the power 3 divided by 18,000. Okay, so we have P as 9,815 newtons, which is the same as 9.82 kilonewton. All right, so we know P. Again, he said we should find the corresponding normal stress. So the normal stress is the stress from the load. So it's going to be the load divided by the cross-sectional area. So it's going to be the load divided by the cross-sectional area which is 19.63, and this will give us 9815 divided by 19.63, and this is 500 megapascal. All right, so there we are with the stress. So question 1 has been solved. Now let's come to the second problem. With the second problem, we have a polystyrene rod, length is what? 12. So I'm not going to draw the length and everything again. We're just going to write the values and put it inside. So for the second preamble, the length is what? 12. 12 inches, and the diameter is 0.5 inch. So 12 inch, diameter is 0.5 inch, and what else? And then it's subjected to 800-pound tensile load. And then so P is 800-pound, and then E is 0.45. So P is 800-pound and E is 0.5 times 10 to the power 6 psi. All right, so E is 0.45, so 0.45, and then so we have been asked to determine the elongation of the rod and then the normal stress. Okay, so elongation is the delta, okay, which is given by PL over AE. All right, so let's calculate the diameter, the area, which is pi into the diameter, which is 0.5 squared over 4. So it's going to be pi multiplied by d squared over 4. And what is that? 0.196. So 0.196 squared inch. Therefore, our elongation will be P, which is 800, multiplied by L, which is 12, divided by the area, which is 0.196, and then we have the E. E is 0.45 times 10 to the power 6. 0.45 times 10 to the power 6. Therefore, delta will be 800 multiplied by 12, 0.196 multiplied by 0.45 times 10 to the power 6. So that is the elongation for you. And what are you getting? So the elongation is 0.08. Okay, so let's say 0.11. So 0.11 inch. That is our elongation. Now the next part of the problem says we should calculate the normal stress in the rod. So the normal stress in the rod is the sigma, which is as a result of the load. So it will be the load divided by the cross-sectional area, which is 0.196. So it's going to be so 800 divided by 0.196. So it's going to be 4081.63. 4081.63 psi. In other words, sigma is 4.08 ksi, or let's say kpsi. In fact, it's the same as ksi. So that is your sigma. So the second problem has been solved. The last problem in this set, a nylon thread is subjected to 8.5 Newton tension force. So again, the load Okay, so the load is, the load is 8.5 newtons, and then we experience, okay, then Young's modulus is 3.3 GPa, which is gigapascal, and then the length of the thread increases by 1.1%. Okay, so E is 3.3 gigapascal, and then the strain. So let me talk about this. When he says that the length increases by 1.1%, what this means is that if I express the length as a percentage, so if I want to express the length as a percentage, it's going to be the change in length over the original length times 100. So this is the percentage he's talking about. Meanwhile, this is the strain. So essentially, what he's talking about over there is actually the strain or the percentage strain. So in other words, if the percentage strain is 1.1%, then it means that there has been an increase of what? 1.1%. Simply put, the strain is actually 1.1%. That's all. And what is 1.1%? So 1.1% will be 1.1, 10. So percent is like divided by 100. So it's going to be 0.011. Okay. So whenever you see the strain expressed as a percentage, that is what it basically means. So we should determine the diameter of the thread and then the stress in the thread. So to find the diameter, okay, so what do we know? So we know that the strain is actually the change in length over the original length. All right, and this is 0.011. So meaning that delta will be 0.011 multiplied by the length. But we know that delta is given by PL over AE. Okay, so since we know delta as 0.011 L, it will be P. Okay, we know P, which is 8.5, and then L divided by the area multiplied by 3.3 gigapascal. So since I want the length, the area, let me convert the gigapascal to megapascal so that I will get the area in terms of millimeter squared. So this one will be E will be 3.3 times 10 to the power 3 megapascal. If I do that, I'll be able to convert it to megapascal. So L will cancel L. Therefore, the area will be 0.011 multiplied by 3.3 times 10 to the power 3. Oh no, sorry. The area will be 8.5. And then I will divide it by, so 8.5 divided by 0.011 and then multiply by 3.3 times 10 to the power 3. Okay. So that is it for you. And the final area is going to be 8.5 divided by 0.011 multiplied by 3.3 times 10 to the power 3. So basically the area is 0.234 millimeters squared. So that is the area. So we can now find the diameter. Okay, so the diameter will be pi d squared over 4, which means that the diameter will be square root of 4 multiplied by the area divided by pi. So it will be 4 multiplied by 0.234 divided by pi. And what is that? So square root of 4 multiplied by 0.234 divided by pi. And this will give us 0.546. So let's say 0.55. So let's say 0.55 millimeters. Okay, so that is the diameter. And then we've been asked to find the stress in the thread. So the stress, okay, let me do it here, this here. Let me do it here. So the stress is the E multiplied by the epsilon. So we can see that our stress will be 3.3 times 10 to the power 3, then multiply by 0.011. Okay, so that is what? So 3.3 times 10 to the power 3 multiplied by 0.011. So the stress is 36.3 megapascal. All right, so this problem has been solved. I think we are done with all the questions. Yes. So thank you very much for watching.